Welcome to this next class of Jam Physics. In this class, we are going to learn about a method that will help us calculate some important configurations or very difficult problems that cannot be solved by using any other method. The method is called as a image method. This method can be applied only when we have grounded condition. What do you mean by grounded condition? Grounded condition means when the potential on that surface will be zero. For example, a infinite sheet which is grounded. The potential on the sheet will be zero, as well as a spherical conducting surface which is again grounded. It should be grounded. Then we can apply this image method to solve the problem. The image method is actually expansion of the Poisson's equation that we have seen, where del square V we have got minus rho by epsilon naught. We had applied this for different situations where potential on a boundary was known, and we had taken the potential at infinity to be zero, and this potential was known, and we had used to calculate the potential or the electric field between different points. Okay, let us see first condition, that is infinitely grounded sheet. For example, suppose we have this charge which is a positive charge plus q, which is present in front of this infinite grounded sheet at a distance d. We are asked to calculate the force on this charge plus q. Now it is a grounded sheet, so the potential on this surface is zero. Now what is going to happen is that this sheet, when it is grounded, before it is grounded, let us say this positive charge comes. This positive charge is going to induce negative charges on this surface, and when it is grounded, okay, and on the other side of this sheet, positive charges will be induced. When it is grounded, the positive charges will be going to the ground, and the potential here will remain zero. There should be negative charges, opposite charges should be there on the surface, so that the potential on the surface becomes zero, because this positive charge is going to create positive potential. As we know, the formula for potential is kq by r. Positive charge will create positive potential here, so negative charge should remain on this surface to create a negative potential, which will make the total potential zero. Now we are going to modify this configuration, because solving this will be very difficult by considering what is the charge on the surface, and also the charge on the surface will be not symmetrically distributed, so it is difficult to use even Gauss law here. So what we are going to do is use the image method. Now how does the image method work? This, let us consider these points. If a positive charge is there here, and if we consider a negative charge here and calculate at the same distance d, we know that the potential at this point, at the midpoint, will be zero, because what is the formula for potential? It is kq by r. This positive charge will create positive potential, whereas negative charge will create negative potential, and the total potential at this point will be zero. Similarly, other points also we can calculate and see. At all the other points also the potential will come zero. So we will modify this configuration, and here we will take a negative charge at the same distance from this surface, that is d. This charge that we have taken is called as the image charge, and hence the method is also referred to as image method. Now we can easily calculate what is the force on this charge plus q. We'll be calculating force on this charge plus q, the charge density on that plate, and the energy of the configuration. Okay, what will be the charge induced on this plate, the charge induced on this plate will be definitely negative minus q, but it will be randomly distributed, it will be unsymmetrically distributed. That is why it is difficult to calculate. Okay, let us calculate the force. Now we have considered this minus q charge at a distance d from the surface, and we have this plus q charge, which is the actual charge at distance d from the surface. So what will be the force? Force we can use k q square. Now one charge is minus and the distance square of the distance between them, that is 2d bracket square. So we will get minus kq square by 4d square. This will be the force on the positive charge. Okay, let us calculate now the charge density. Now to calculate the charge density, sigma, okay, what we'll be doing is we'll be finding the net force on a point. We'll consider a point on the plate, and this we know that E net is equal to sigma by epsilon naught n cap. N cap is perpendicular drawn to the surface. Okay, so we'll be considering a point on this plate. Let us consider this point A. We have minus charge here and plus charge here. So this distance we will have to calculate. We know this distance is d. Let us take this distance as r, and we'll have to calculate this distance from negative charge to A. This distance will be simply square root of r square plus d square. This will be also square root of r square plus d square. So the net force, to calculate the net force, one more thing we will have to see is in what direction these points are. So let me draw the triangle here again. This is r, this is d, and here we have negative charge and here we have positive charge. This is the point A. The positive charge will be pushing this test charge because we have considered a positive test charge here. The negative charge will be pulling it towards it. So if we consider this straight line here, let us consider this angle as theta. This angle will be also theta. Now consider this negative charge also. This angle will be also theta for the negative charge. Let us say this is E plus and this is E minus. Now the net force will be E cos theta, E plus cos theta plus E minus cos theta. So we will have there will be addition. Now we have considered the directions also. There will be addition of E cos theta. So we will have E plus cos theta means what we have, kq square divided by the distance. Distance is root of r square plus d square. And E minus cos theta is also same, kq square. I have taken small q, so let me write small q here. Distance will be same, r square plus d square. Now this E net, as you can see, it will be in negative I cap direction. Negative I cap direction. So let us write the direction here, negative I cap. So this is the magnitude and this is the direction. So what we are going to have is just 2 kq square divided by square root of r square plus d square in negative I cap direction. Now this net force we can equate with sigma by epsilon naught in n cap direction. Now n cap direction means perpendicular to the surface. The surface, we have considered this to be the surface. So perpendicular means it will be in positive I cap direction. Negative I cap direction actually does not exist. Their image charge is there. So, and also you can consider this negative charge will be induced on this surface. Negative charge will be induced on the surface, and we have put a positive charge here. So the electric field will be from positive to negative charge. Positive to negative charge. So the n cap will be in this direction, that is positive I cap direction. So let me write this positive I cap. So we have sigma by epsilon 0 positive I cap, and here we have calculated net electric field as 2kq square by root of r square plus d square. Here we have got negative I cap direction. So we can cancel this I cap. Negative will be there. Sigma will be equal to 2. Let us write the value of k also. It will be 4 pi epsilon naught into epsilon naught we have from this side q square. Now this r square. Now we can also take r. R square will be equal to y square plus z square. Because remember, we had taken the plate in y and z direction. We had taken the plate in y and z direction. So r square will be equal to y square plus z square. Some z square and some y square. So we will put that value also here. It will be square root of y square plus z square plus d square. So we can cancel this. 2 epsilon naught will get cancelled, and sigma you will get as q square by 2 pi root of y square plus z square plus d square. Remember that when you have to calculate the net electric field for even the sphere or the plate, consider a point on that and calculate the electric field, the net electric field due to the charge configuration, both the actual charge and the image charge, and just equate it to sigma by epsilon naught n cap. You will get the charge density. The induced charge here will be minus q, opposite of whatever the actual charge is there. Okay, the last thing we have to calculate here is the energy of this configuration. Now to calculate the energy of this configuration, what we will do is we will imagine bringing this charge from infinity. From infinity, we'll consider this charge bring plus q. We will have to bring it from infinity to this point. Okay, and what we will do is we will use this concept of work. Work is equal to V into Q, potential into charge. Now, potential we will calculate for this negative charge. For this negative charge, what will be the potential? It will be minus kq by the distance. The distance is 2d. And the charge which we have brought here, or the charge which we are going to multiply, is the positive charge q. So work done, we'll take here, so work done will be minus k, let me write that value, 4 pi epsilon naught into 2d. Now we have both the q's, it will be q square. So this will be the work done, but now this will be not actually the work done. We will have to take work done is equal to half what we have calculated. We will have to take half because that negative charge which we have considered does not actually exist. So let us multiply this with 1 upon 4 pi epsilon naught into 2d. We have q square. That means we are going to get 1 upon 16 pi epsilon naught d and q square. This will be the actual work done to bring the charge. Remember that calculate the potential and multiply it with the charge, but also multiply it with 1/2 because the image charge actually does not exist. Okay, let us look at the next question. In the next question, we have two plates. Instead of one plate, they have given us two plates. This one side and on this side. So we will have to again calculate the force on Q, and we can also calculate the other values. Okay, now in this case, what we are going to do is we will consider this is the positive charge. Again, we will be using the image method. This is at a distance d from the plate. So we will consider negative charge at a distance d from this plate, and another, this is also d. So we'll consider here one more charge minus q on this side. Now see, okay, this will these plates are grounded, so the potential on this should be 0. Now if we take this configuration, see, now because of this positive charge and this negative charge, the potential here will be 0. But now this negative charge will also create a potential here. So we will have to put another charge which will at same distance from this minus q charge, but in opposite direction. We'll consider positive q charge. Now see, because of this negative charge and positive charge, the potential will become 0 on this plate also. Now how to know how many charges to take, that we will see in the next question. So here 4 charges we will have to consider. Now the potential on this plate will be 0. So now it is like a square. Now we can easily calculate the force on this q charge. So let us consider that configuration here again. We have positive charge here and negative charge here. The distance between them is 2d. This distance is 2d. Here we have one more charge minus q. Again this distance is also 2d. Here we had to take plus charge. This distance is also again 2d. It is a square. All distances are 2d. See, this negative charge is going to pull this positive charge. This negative charge will pull this positive charge, and this negative charge will also pull this positive charge. Now the resultant of this, both these forces F1 as well as F2 will be equal because distance is same. So the resultant will be in this direction, and due to this positive charge there will be a repulsive force on this. So we will have to calculate, let us call this as F3 and this is the resultant of this both. Now we know that this angle is, it is a square, so this angle will be 45 degrees. So first let us calculate the F resultant. It will be just F2 cos 45 and F plus F1 cos of 45. Both angles are 45 degrees, so we can take just the cos. So F1 means sorry, F2 means, put the values of this here. F2 will be equal to kq square by 2d square, that means 4d square we will have, and cos 45 means 1 by root 2 we will have, plus we will have the same value 4d square by 1 by root 2. Now negative charge I am not considering because we have already considered the directions, so we are just adding them. So we'll get 2 kq square by 4d square into 1 by root 2. That means directly we can write this as root 2 into kq square by 4d square. Now for F3, For F3 we will have to find the distance of the diagonal. Now it is a square, so this is D and this is 2D and this is also 2D. So this will be this diagonal, let me write it here, diagonal will be square root of 4D square plus 4D square. That means we can write this as diagonal will be equal to D will come outside and we will have root of 4 plus 4, that is 8. That means it will be 2D into root 2. 2D into root 2. Diagonal will be this much. So F3 will be KQ square and it will be directed in this direction. We have a positive charge here and a positive charge here. So KQ square by 2, that means 4D square, and root 2, that means we'll get 2 here. So we can write this as KQ square by 8D square. Now we can easily calculate the net force. The net force will be F resultant minus F3. So we will take F resultant, what we had, root 2 KQ square by 4D square, root 2 KQ square by 4D square minus this we have KQ square by 8D square. So we can take this KQ square by 4D square common, and inside the bracket we will have root 2 minus 1 by 2. This will be the net force on the charge Q. Okay, now let us look at the next question. Now in the previous question we had taken 3 image charges. Now how to decide how many image charges to take? So we can use this formula to find out the number of image charges, which is 360 by theta, whatever is the theta between the plates. In the previous question we had 2 plates at 90 degree. So we can put here 90 degree minus 1. So for the previous question you can see that 360 minus 90, we will get here 4 minus 1, that is 3. That is how we got 3 charges. If the angle is 45, you can divide and find out. So remember this formula, it will tell you number of image charges to be considered for the image problems. Now let us look at the next question. Now in the next question, instead of a charge, we are given a dipole, but we will have to use the same method. Now this plate is grounded. We have at a distance D we have a dipole. So what will I consider is a negative charge and a positive charge, So on the other side also I will have to take images of these 2 charges. So for negative charge at this distance D, this distance is D is given from the, okay, let me write this properly. This distance D is given from the center or the midpoint of the dipole. So at the same distance from here I will have to first consider a positive charge, and for positive charge the image charge will be negative. The midpoint again I will have to consider at the same distance D from this plate. So see, this dipole will be also in this direction and this dipole is also in this direction. The magnitude of both these dipoles will be same. Now they have asked us to calculate the surface density. Now to find the surface density, as I have told you, select a point on the plate and find the net electric field. Now if you remember, for the dipoles on a axial point, for the dipoles on the axial point, the electric field will be in the same direction. So for this image dipole, it will be in this direction, as well as for the actual dipole it will be also in the same direction. So the net electric field will be E plus E. That means we will get 2 times E. Now what is this E? We have seen in the dipoles how to calculate the electric field for a point on the axis. The formula is Kp. P is the magnitude of the dipole divided by r cube. R is the distance of the point from the axis of the dipole. We have 2 cos theta plus sin theta. Now here theta is going to be 0, so we will get 2 kp by r cube. Cos theta is going to be 1 and sin theta is going to be 0. Now here we have E plus E. That means we will have E net, this is E net. E net will be equal to 2 into this 2 kp by r cube. Now r cube means it is the distance, so we can write d cube. Distance from the midpoint of the dipole is d, so it will be d cube. So what we will get? We will get 4 kp by d cube. Now we can equate this to the sigma by epsilon naught. So sigma will be equal to 4 kp epsilon naught by d cube. We can put the value of this k will be 4 pi epsilon naught. We have p epsilon naught in numerator and d cube. Epsilon naught and epsilon naught will cancel, 4 and 4 will cancel. We will get p divided by pi d cube. P divided by pi d cube. Now here the net electric field, if you see, it will be in positive I cap direction, and this sigma, which is perpendicular to the surface, will be also in positive I cap direction. So the directions will be same. We will get surface density is equal to P divided by pi d cube. Okay, now let us look at the next question. Now the next condition is for the spherically grounded conductors. Now for spherically grounded conductors, suppose there is a plus q charge outside and this sphere is grounded. That means the potential here is 0. The potential here is 0. Now what is going to happen? Where to take this image charge? Now for the plane surface, what we did was the image charge we took at the exact same distance where the actual charge was present, but in opposite direction. We took here minus q charge. Now in case of a sphere, that will be not the case. The image charge, yes, it will be negative, but it will be not at the same distance from the surface, but here the surface is curved. So let us see how to calculate this distance and how much charge the image charge will be. Because the image charge, let us say this is the image charge will be not equal to the actual charge. So we'll have to calculate the distance as well as the magnitude of the image charge. So let us consider this sphere here again. Here we have positive charge outside. This is the center of the circle. This distance is radius. The distance between this is given as d. Now let us consider the image charge somewhere here at a distance x from the center. At a distance x from the center. So this image charge is at a distance d minus x from this positive charge, d minus x from the positive charge, and at a distance x from the center. Now see, we will have to consider 2 points on the sphere. Let us say this is point A and this is point B. Now at point A, what is the potential at point A and point B? It is on the surface of the conductor. So the surface of the conductor always has the same potential, and the potential here is 0 because it is grounded. So we can use this condition to find the charge and the distance, because now this image charge which we are considering, let us call it Q dash, both will create the potentials here. So at VB, the image charge will create the potential K Q dash, and what is the distance from the image charge? It is, see, from here to here. Now I am not able to draw here. This will be R and this is X. That means it will be R minus X. This distance will be R minus X. So it is at distance radius minus X. This will be the potential due to image charge, and potential due to the positive charge will be KQ. Okay, here this will be D minus R. This will be D minus R. And now this is equal to 0. Okay, so KQ we have common. Again, one more condition we can write, that is for point A. Let me draw the sphere here. Point A is here. This is the center. This here we have the Q dash charge and positive Q is here. This distance we know is D. So for this point A, again we will consider the image charge Q dash. Now here the distance, this distance is X. So it will be R plus X for Q dash, and for the actual charge it will be D plus R. So we have now both this VB and VA are equal. VB and VA are equal. Okay, now here we know that this VB is equal to 0. VB is equal to 0. So we will have KQ dash plus R minus X KQ D minus R. We will equate this KQ dash R minus X is equal to minus KQ D minus R. Same thing we can do for the other equation. 0 is equal to KQ R plus X plus K, I think so it is KQ dash, yes, KQ D plus R. If we equate this, KQ dash will be equal to R plus X minus KQ D plus R. Let us call this equation number 1 and this equation number 2. Now let us divide this equation number 1 divided by equation number 2. If we divide these equations, we will have KQ dash R minus X divided by KQ dash R plus X. R minus X and R plus X. On this side minus KQ, sorry, let me write it properly, KQ D minus R, minus sign we have here, and minus KQ D plus R. So here we can cancel this Q dash as well as Q. K will also get cancelled, minus sign will also get cancelled, a lot of things will get cancelled. This is denominator's denominator, it will come in numerator, and this R minus X will go in denominator. D plus R will be in denominator, D minus R will be in denominator. Now let us cross multiply this. R plus x into d minus r is equal to d plus r into r minus x. Now if we multiply this, we'll get r into d minus r square plus xd minus r into x. On this side we are going to get rd minus dx, d into minus x, plus r square minus r into x. Now let us see what are the terms that have same signs that will get cancelled. Minus rx and minus rx will get cancelled. Again we have rd which will get cancelled. This side also rd will get cancelled. We'll have minus r square plus xd is equal to minus xd plus r square. These are with opposite sides. So we'll send on same side r square minus r square, we'll get 2r square, and xd minus xd minus xd, that is 2 times xd. So we will have 2r square is equal to 2 times xd. Minus sign will also get cancelled, 2 will get cancelled. We will have x is equal to r square by d. Now this is an important equation. This will tell us where to place this image charge. Now we will be putting this value in one of these equations to find the magnitude of the charge. Now let us see which equation we can put. We had this first equation. We'll put the value in the first equation. So we have first equation kq dash, I think so, we have r minus x kq dash r minus x is equal to minus kq d minus r. kq d minus r. Okay, let us put the value of x here. So we will get, instead of x, let us put here only r square by d. K we can cancel. So here we will have q dash. Let us take this r common. We'll have 1 minus r by d is equal to minus q. Here we will have d minus r. Okay, let us multiply this d here. We have r, sorry, we have q dash r, we'll have d minus r by d, which will be equal to minus q d minus r. So see, we can cancel this d minus r on both sides. This small d will go in the numerator. Q dash d will be equal to minus q. So finally we'll get the value of q dash, which will be minus q capital R divided by small d, where d is the distance from the center to the actual charge. So we have both the equations where to place this charge. X we have r square by d, and we have an equation for magnitude of the charge as well. These both equations are important. Now suppose if the actual charge is not outside but inside, then the image charge will come outside. Again, we can use the same formulas to find the magnitude of the charge and the distance of the charge. Now in this case, see, this d will be smaller because d is the distance from the center to the actual charge. D will be smaller than r, so x will be larger. x will be larger, and we will get the charge outside outside the sphere. And the magnitude you will be able to calculate by using this formula. So these both are important equations. So this is all about the image method. You may be asked to calculate problems regarding the infinitely grounded sheets, or you may be asked to calculate for the grounded conductors. Thank you.